Okay, I think we're ready to go. My name's Louise Walker and I'm Senior Research Manager at CIRIA and susdrain. Thank you for joining us today for our webinar on highlights of the Ignition project. Before we begin, I'd like to cover a few housekeeping points. Today's webinar is being recorded. All attendees are in listen-only mode. If you have any problems with your connection or audio, please send us a message via the Q&A box and one of the CIRIA team will try to help. There'll be plenty of time for questions after the presentations. During the sessions, please could you type your questions into the Q&A box. Please state if you wish to direct your question to a particular speaker. Please do share your views and experiences with us at SudsUlike and using the hashtags SudsIgnition and GM Green City. We'll aim to finish at 12:30. I'd like to say a quick thank you to all our susdrain partners and supporters, without whom events such as today's would not be possible. So what brings together today? Since 2019, the Ignition project has explored how Greater Manchester can accelerate the delivery of urban nature-based solutions to build a climate-resilient city region. Supported by the Urban Innovations Action Fund, the project brought together 12 partners from local government, universities, NGOs and business to develop pathways to accelerate public-private investment in nature-based solutions. One strand of the project focused on collaborative investment approaches, tackling urban surface water flooding by identifying hotspots for multi-partner investment in urban suds retrofit and piloting the development of an urban suds neighbourhood. It also tested a replicable methodology for the adaptation of sewer models to represent suds. This webinar, hosted by CIRIA susdrain community, will present an overview of the Ignition project and then provide a deep dive into the suds neighbourhood pilot, focusing on the planning, modelling and impact evaluation of retrofit suds neighbourhood in Walton, Salford. We'll first have an overview of Ignition and then a presentation on planning, conceptual design and cost estimation for retrofit suds, followed by retrofit suds modelling methods and outcomes. And we'll have an interactive discussion and Q&A at about 12:05. So I'm delighted to be joined today by Matt Ellis, Climate Resilience Lead at the Environment Agency, Phil Williams, Technical Director at the Environmental Protection Group, and Bridget Ballard, engineer at HR Wallingford. So let's begin the first presentation by Matt Ellis, Greater Manchester Climate Resilience Lead at the Environment Agency. With over 20 years experience as a qualified planner, it's Matt's belief that the critical ecosystem services our natural environment provides need protecting and planning for, just as we would for any other piece of critical infrastructure. Over to you, Matt.
Brilliant, thanks, and hopefully you can all hear me. And thanks for letting me come and talk to you this morning and the introduction to the project more generally, a little bit about Ignition and suds. What I'm hoping to do as this sort of scene setting, a little bit about Ignition, I'm going to touch on that, the suds ambition within the project, and then I'll start the journey around developing the suds co-investment opportunity, which will hopefully then hand over quite nicely to Phil and Bridget to provide a little bit more details about the walked-in experience. What is Ignition? As we've heard, it's a kind of Urban Innovative Actions EU-funded project. It stands for Innovative Solutions for Investment in Greater Manchester's Natural Environment. I came up with the acronym I can never remember, but if you take a few jumbled letters out of that, you get the word Ignition, and a good acronym is important for any project. And it's worth saying that it's not about new MBS solutions coming up with new technology. What this was around was specifically, as we've just heard, about developing innovative financing solutions and delivery solutions to actually get this sort of nature-based solutions, particularly SuDS, invested at scale within Greater Manchester and our urban areas. Just before I sort of start talking a little bit more about SuDS in the project, a couple of the early outputs from the project, which will sort of hopefully make sense in terms of the scene setting. We did quite an in-depth, about 1,000 articles, research papers, professional journals, evidence review, baseline evidence, to really bring together the state of the art in terms of research, to understand the costs and the value and the kind of monetary value and what the research is telling us, particularly to allow us to start building investment and business cases. And that exists, and we'll share all the links to some of the wider project resources after the webinar. And that will allow ourselves and other partners to start understanding and building investment and business cases. The second image here on the slide is of the Ignition Living Lab at the University of Salford. Major capital investment, the only real one in the project. Actually really quite an inspirational seeing is believing space, so people that work in this area can go along and see and feel and touch. But again, this is all about understanding the performance and costs of these types of nature-based solutions. So how much water are they storing? How much energy does a green wall actually save a building in terms of insulation, biodiversity, etc., etc. And within Ignition, these are called funding streams, and we looked at a number of these. So really here, what we were trying to do was develop business propositions, income around these nature-based solutions. So we've looked at parks, existing and public, and looked at how you can bring more funding in to do more with parks, particularly around kind of their functions for people in the environment and climate resilience. We looked at green roofs, mapping the city centres of Manchester and Salford to understand at a high level which roof spaces could accommodate quite easily a green roof, and then we provided tools that's allowed building owners to actually start to assess their assets. And we did quite a lot on SuDS, and particularly SuDS retrofit, which I'll come to now, looking at both individual sites, SuDS retrofit, and kind of more neighbourhood scale, which is what we're talking about with Walkden. The project itself had a wide ambition around SuDS anyway from the outset. As you can imagine, it's a climate adaptation project. The ambition here, or what we set out to do, was to design and develop and pilot investment cases, so in the multiple for retrofitting SuDS in GM, replicable, multi-benefit, multi-partner, public and private sector. Before I kind of go into sort of talking about the co-investment sort of work that we did around neighbourhood scale SuDS, just want to reflect here, because it starts to again set the scene for what we did with Walkden. We all know that nature delivers value. Some of that's actually financial, monetary value, but we also probably know, and if we didn't, the Ignition project helped focus our minds. It's a long and, as I say, complicated and winding road to capture that value and to get people to pay for it. It's a project around investment, and things and tasks like benefit identification, identifying beneficiaries, technically assessing MBS interventions to make sure that they are possible, assembling often small scale kind of things into a wider pipeline, setting up and understanding how the different beneficiaries are going to fund it, how you're going to procure it, if they need paying back or if they need to be understanding of a certain level of performance or other outcomes, how are you going to monitor it and verify and validate that you've done what you've said, potentially to multiple parties. And that makes it inherently quite complicated. And that's really what Ignition was trying to unlock. We focused specifically on a SuDS co-investment opportunity. And here we were looking at understanding how we could collaboratively finance and deliver public realm SuDS. So working in partnerships, delivering results within the water management network kind of improvements, resilience to climate change, and enhancing natural capital. We kind of looked at this in three sort of ways. We spent some time exploring a value proposition for SuDS from different operational investors and beneficiaries. And we'll come back to that kind of different organisations in a minute. We obviously wanted to understand and trial this somewhere, so we looked at strategic locations for this co-investment to take forward into a case study, which Phil and Bridget will talk a lot more about. And we then worked with HR Wallingford and Phil to do that piece of work and test that for a case study. And turning for the first thing, we spent some time mapping benefits. This was driven obviously by a quite well-known set of benefits you get from SuDS, which you can see on the left here. Also the evidence base that we'd seen, and we started to try and understand the beneficiaries that we had, sort of locally and more generically, and understand the value proposition for them. And as you can see, we've probably even missed some of the lines out here. It got quite messy quite quickly, and linking up the benefits to the beneficiaries, talking to those beneficiaries about the investment, potentially talking to multiple beneficiaries about investment, all of which have different organisational setups, maybe different regulatory regimes, different funding, different timescales. And actually that's some of the barriers that we already understood but perceived that we would need to overcome in terms of ignition, in terms of a replicable process that could really deliver this sort of stuff on co-investment on the ground in SuDS. We did decide maybe to give ourselves a slightly easier time to concentrate very specifically on water management benefits and beneficiaries. So what this led us to do with our local authority partners as well, and United Utilities, so Manchester City Council, Salford City Council, United Utilities, was really to sort of focus on their water management benefits from SuDS, understand how these map together, and really start to drill down into data and evidence, so historic sewer flooding events, surface water flood risk, historic flood events. We were also very interested in the efficiencies and cost savings that might be achieved through muddying up with grey infrastructure, so highways. So they were kind of within the local authority stakeholder group. So looking at highways investment and reconditioning programs, trying to understand where these things exist in space, and where we have all of these things. And we were really well supported by our project partners in providing this data and helping us steer us on this journey, particularly Salford City Council, who have been working around SuDS and sort of SuDS in highway schemes for some time and doing a lot of thinking, put them in a really good place to help us, get us the data, steer us, help us work with United Utilities. So all of this kind of was us narrowing down to where we could start to identify that location for a case study. And that location, as was mentioned earlier, is a town called Walkden in Salford. I apologise, I'm sure this is far too small, but I'm sure the slides would be shared. About 7-ish kilometres to the northwest of the Manchester city centre, 35,000 residents, has a history of surface water and sewer flooding, has already planned in highways investment, has some sort of other areas of kind of public land, registered social landlord housing, and ownership of the kind of street and street margins. And through working closely with Salford and with United Utilities, Walkden was identified as an area where we were getting a lot of those synergies and opportunities existing in one place. At this point, though, we didn't have individual swales or such features or really specific locations. So that was a kind of a deeper dive to really understand which neighbourhood we could trial something. That was the case study. That's when we brought on board EPG and HR Wallingford and started to think very much about what might be possible, what might the detailed designs and costings be, and also very importantly, what would actually the performance of any given sort of SuDS neighbourhood scheme do for the various beneficiaries that I spoke about in the previous slides. So that's where we ended up, and hopefully this hand over now to Phil, who should be able to start to sort of expand on what we actually did and what we looked at in Walkden.
Hi, I'm Phil Williams. I'm Technical Director at the Environmental Protection Group, and we were asked to look at the retro SuDS planning, conceptual design and cost estimation part of this development. Is it a SuDS presentation without the 4 pillars of SuDS? But it is important to have this in there because we use these 4 pillars to identify and to run our designs against them. So not only were we looking at the water quality and water quantity, we was also looking at the amenity and the biodiversity values of each of the retrofit SuDS principles that we were putting into the system, into the area of Walkden, which borrowing Matt's slide, you can see where it is in regards to Manchester. It's a small town within Salford, but this image, which was taken from Scalgo, where we use LiDAR, identifies the fall across the site. So the north of Walkden, what is about 50 metres to 75 metres higher than the south. So there was quite and some of these falls are fairly steep across some parts of the site, and then it shallows out on other parts. So we had a lot of gravity issues to play with. We knew that there was a certain direction in which all the water fell, and that allowed us to identify some of the more suitable areas, as well as excluding some of the other areas just for the fact that the gravity system, that the falls didn't work within those areas. So we've got two slides here identifying the sites that we looked at. So these ones were with Wilbraham Road, Mearside Road, Leaside Road, Springside Road, Whittle Street, and Manchester Road. And Manchester Road is more of the park on Manchester Road rather than the road itself. There are other areas within this site which would have been suitable for SuDS, or on initial aspect looked suitable for SuDS. But one of the most important things, if anyone was going to do this project again, would be physically walking across the site. And as you walk across the site, you realise some of the constraints that maybe these areas have, that they might be at the top of essentially a catchment with no way water could get into these green areas, or there was a lot, or there might be a lot of existing good quality trees, or there might be real potential for a lot of services beneath them. So having a site to walk across was critical, and I did that a couple of times, and then myself, Bridget, and the Ignition team also did a final walkover, which allowed us to identify these areas and these areas as well. So the site, the area was split by the railway site, the railway tracks. So south of the railway tracks, we had Walkden Park and Ride, Walkden Road, Birch Road, which due to the length of Birch Road, we split east and west, and then Rydale Crescent and Tarn Grove Crossing. We looked at, as part of the site was replicability of the SuDS solutions. We looked at more common SuDS features, so fire retention zones, swales, rain gardens, pervious pavements, tree pits, while keeping some of the more new and unusual ones, such as maybe blue roofs, smart systems, out of the study, just so someone could pick up this project and look what we've done, and then say we can copy that, we can do this design on our area of land without having to have some real sort of key inputs and key understandings. So for each of the areas that I identified, we looked at them and we undertook a design. We calculated the attenuation volumes. We then did a cost analysis and then a benefit analysis, and that was for each and every one of them. And what I've done here is I've extracted some of the more either unusual ones or ones that give a good flavour of what we've done. So the first one is Wilbraham Road, and what we used is we used the same Scalgo LiDAR measurements to look at the falls across the site. So from the top road down to the bottom houses, you're looking at about 3 or 4 meters of fall. So what we proposed within the design, so we had had the site walk over, and as you can see, there's also 2 good quality trees and a new tree there, which we could probably, as we're excavating, pick up and replace and put elsewhere. We come up with this solution where it was a bioretention zone, which was draining the road to the north and to the east of the site, blocking up a number of the existing gullies there, and then connecting the road into this bioretention feature. Because of that 3-meter fall, which we just discussed, we've put in a number of earth check dams, so all the water just didn't run right the way down through the bioretention zone and overwhelm the bottom of the SuDS feature and then flood the road at the bottom. The maximum depth of these features, they varied between 200 mil and 500 mil, but we tried to keep them fairly consistent where possible, or about that 300 mil open water mark during the key peak storm event. And each of these systems would connect back into the United Utilities asset. And what we used is the minimum allowable connection with the minimum allowable orifice size of 50 mil to then connect into United Utilities. So rather than giving ourselves 1 litre a second, 2 litres a second, we had that minimum orifice plate, and that was the key restriction for these retrofit SuDS features. We also undertook a landscaping review. So we produced a list of critical and important landscaping product planting schemes that you could use on these sites, and they tied into the Salford landscaping scheme. And we undertook this nice graphics to show how the site would look when it was finished. One of the big issues when you're doing retrofit SuDS is constraints. Certainly in heavily urbanized areas like Walton, is you would have services, lots of services, water, gas, cable. Some of them, they'll be generally variable in depth, but we're anticipating they start from about 750 to a metre down below the ground. So keeping things shallow often benefits by avoiding these services. And we also expect some of them will be marked, whereas some of the others won't be marked. So we anticipate gas would be marked, but maybe cable wouldn't. Obviously, some of the sites we identified we dismissed because of services, because one of them had a significant amount of cable boxes and electricity draw pits close by. So that would be a real big constraint, and it would be difficult to dig anywhere in that location. A lot of these areas had sort of natural tree growth, so there didn't seem to be any specific planting arrangement, just trees had grown there over time. Some of them were good quality, some of them were poor quality. The ones that were poor quality we suggested removing, and the ones that were good quality we designed the features around them. But there were some that obviously had been taken down for one reason or another, so there was also tree roots and tree stumps that wouldn't need to be managed while when you're doing the retrofitting. And then also a key thing, as I said before, we had connection into United Utilities sewer, so we'd need to understand the connection levels, where again keeping things shallow is critical, allows us, makes it much easier for us to connect into the existing sewerage system. Again, one of the things we identified, or we assumed, was that there was no contamination and there was no high water table. But that would be, we would suggest site investigations be done prior to any work on these or any other retrofit SuDS around the Manchester area. And one of the key things is this area is very urbanised. There's a number of schools and a number of primary schools. So on any of these walking routes to the primary schools, we try to keep the depth of the water fairly shallow, just to avoid any health and safety issues with children having to fall into these or hurt themselves. And then when full, we suggested that the velocity of the water movement through the open water was very low as well. What we did for each and every one of these sites is we undertook a cost analysis. So the Wilburn Road, we identified that there was £13,000 worth of material cost. There was earthworks and a large component, and then on top of that earthworks, there was disposal of the soil. This disposal would increase in cost if there was any contamination, but we considered it clean. And then we identified an annual maintenance charge cost to maintain this area. One of the things to understand is we try to keep everywhere as independent, as separate as possible. So someone could come along and do one zone, but what that did is it added costs to the earthwork, to the groundworkers' mobilisation costs. So if you were going to do 2 or more of these retrofits, there would be a cost savings because the groundworker wouldn't need to mobilise twice. We also undertook the best analysis, and what the best analysis, the image, this might be a little bit small for you to see, but when you receive the presentation, you'll be able to see it in better quality. Identified the areas of best benefits, and the big one was health. We didn't really look at the best qualities for water management because that is what Bridget will be doing later in this presentation. So we excluded water from our benefits. So these values, this net 17,500 value, excludes the water benefits as well. So there is greater value to it than what's being shown here. And these are the factored improvements to the locals for having this green space, and the benefits that the locals will appreciate by us implementing the retrofit SuDS. The next one we did was Manchester Road Park. This was a large park, so but there was an area which wasn't being used at the bottom of it. So we then looked at expanding a large fire retention zone into this area and taking a large area of the Manchester Road into this fire retention zone. But what we were key to do is avoid actively used parts of the park, such as the football area and the playground. Park and Ride was Walton was also looking at retrofitting this industrial estate into a park and ride. So we proposed changing that from just a traditional sort of hard standing areas to a pervious solution, and the benefits that that would have on the drainage infrastructure, because there would be a significant reduction in volume of water coming from a traditional hard standing impermeable site to one with porous pavement. And what we identified is there's not much of a typical cost, an uplift for pervious pavement and resin pavement. Resin pavement is quite popular now and has the biggest uplift, whereas it was £10 a square metre uplift for pervious block pavement in comparison to traditional pavement. One of the things to note is that uplift might get eaten into the fact that type 3 or pervious gravel is generally 10% more expensive than a traditional type 1, but it also bulks 10% more, so it has a cost neutrality associated with it. You don't need 10% less type 3 than you would do a type 1. So you would probably start to claim back that £10 per square metre by using porous aggregates, which you would need to do. We looked at a number of tree pits. So the first tree pit area we looked at was the busy Walkden Road, where we went with a traditional in-ground tree pit, where we banked 2 sets of 4 trees into this area. You can see here, and we were looking at draining half of the road into these 2 tree pits. And we did a number of sections for these tree pits to show how they would sit within the pavement. And what we also did was a graphic to show how it would look like now and how it would look like once we implemented these tree pits. You can see there's a real big difference to having those tree pits, how much nicer it looks. Birch Road West is a fairly complex site. It was quite long, and it had a number of existing tree pits, as you can, or trees within it. But the locals were using the wide pavement for car parking, and a number of the trees that were there were generally in poor quality if they were there. A lot of them seem to have been reversed into a number of times and had just died. So what we proposed is a more formalization of the parking and the tree pits. So bringing in pervious pavement again to drain the roads with a tree pit system, with the tree roots sat beneath the pervious pavements. Again, we did a graphic of how it looks now, how it could look. Again, I think you'd agree with me, it looks much better if you start implementing these trees. Again, we did a full costing analysis for the whole of the site, including the individual tree pits, where it cost for the pervious pavement, the groundwork, and all the ancillaries. As I said previously, each area is priced individually. So if you're doing 2 or more areas, the more areas that you're able to do, there is a significant economy of scale savings. And then we did a best value for the site. And again, Bridget will lead on into this. We didn't look at any of the water benefits, any of the flooding benefits by implementing the SuDS, because Bridget would be looking at that in much greater details. But one of the things we noticed is we used the bridle and stringer paper from 2009 to price our trees, because they seem to give a much better value to a tree than the best figures at that time. Thank you.
Thanks very much, Phil. Please keep your questions coming into the Q&A box. Questions for Matt and Phil, we'll pick them up in the discussion shortly. I'd like to welcome our final speaker, Bridget Ballard, Principal Engineer at HR Wallingford. Bridget is Technical Director at HR Wallingford, who manages the catchment and drainage team. She's a civil engineer and hydrologist and has been working on research, guidance and standards relating to SuDS for over 20 years. Over to you, Bridget.
Thanks, Louise, and thanks for everyone for listening. I'm going to talk now about how we took the outcomes of Phil's work and looked at how to develop a modelling approach that would most usefully or most efficiently deliver on what the stakeholders were looking for in terms of performance outcomes from these SuDS. So In this presentation, I'm going to cover what the aim, the scope of the modelling work was, what the project stakeholders were looking for, as I said, in terms of what they wanted the modelling to tell them. I'm going to provide some detail on the different modelling approaches that we considered and that could be taken to adding retrofit SuDS into an existing sewerage undertaker sewer model. We're going to look quickly at some of the model outcomes and the constraints and opportunities associated with those outcomes, and then just some high-level thoughts on the transferability of the method to other locations, the challenges that the method posed, and lessons learned in terms of future applicability of modelling approaches. What we were doing within the modelling is taking Phil's outline designs of feasible SuDS retrofit solutions for the Walkden pilot study area, and assessing what those SuDS, the impact of those SuDS on surface water flood risk, and we're looking at the areas of surface water flooding and specifically individual properties and pieces of critical infrastructure. We were looking at the sewer performance from a flooding perspective, and the impact again of that flood risk, both internally and externally to properties in the area. We were looking at the combined sewer in the pilot or within the area of the that the pilot study sat, and how any retrofit interventions might influence that combined sewer overflow performance, and also on the pumping stations, on flows at any pumping stations in the system, and wastewater treatment works. To contain all this and to characterise all this modelling approach was needed to be robust and very clear what we've done, and replicable to other locations in Greater Manchester if such similar pilot studies were rolled out in wider areas. So these were the performance metrics that had been set out by the stakeholders in the project, what they wanted to see in terms of how the SuDS were influencing all this, the system itself, but also influencing performing individually. So we were looking, in terms of the SuDS themselves, we were looking at how much volume was being infiltrated at individual locations and attenuated before being transferred back into the sewer. We were looking at how effective the different SuDS were at different locations in actually capturing runoff, because that's a key. Your SuDS are only going to be highly efficient if they can capture a significant proportion, a significant area of runoff, and how much, and linked to that is how well the storage that was provided at individual locations, how well that was utilised, how efficiently that was utilised in any event. We looked at surface water flooding in terms of extents, flood depths and extents, property counts, critical infrastructure counts, internal and external. We looked at the sewers themselves, the surcharge and flooding return period at sewer nodes, and the actual peak flow rates and volumes within the sewers. And then we looked at, as I said, the combined sewer spills, frequencies and volumes, and the pumping volumes as well. So a lot of metrics, a lot of very detailed metrics, and as you'll see now, those metrics are absolutely key to defining the detail and rigour which is needed within a modelling approach to ensure that you can extract that sort of information. I would say at this point is that actually, before I move on to that, is just to highlight that there was a combination of sewer types in the Walkden area. There were both surface water sewers and combined sewers, and in many places a combination of the two in the same street. So it was actually very complicated to identify exactly where surface water flow paths, which sewer the different surface water flow paths were flowing to. But what we did do is we ensured that wherever we were putting the SuDS in, that those were then reconnected into the surface water network rather than combined. So the different types of SuDS models that we considered and that we reviewed as part of defining this replicable approach, modelling approach for the area. We went right from the very simplest approach to the most complex, looking at the pros and cons and the benefits and the constraints of each. So at very high level, the option one is to take an existing sewerage undertaker as one-dimensional 1D model. Most sewerage undertaker models are 1D, so directly using this model without significant adaptation at all is obviously much the simplest, much the easiest. All it requires here is removing an area from a runoff subcatchment that's representing that area would be representing the area of runoff that would be captured by a SuDS. So you're effectively just taking out and assuming that entire impervious surface area is now not contributing to the sewer. Option two is, and I would say that option one is obviously giving you the highest level of performance efficiency, but not necessarily representative of exactly how the SuDS will operate in practice, because clearly SuDS won't take all the water out for every event. Option two becomes a slightly more intermediate level. It's still working with the 1D model only, but you are adding in a storage and a flow control node to all or part of the runoff subcatchment. So you've got a little bit more refinement in there, but you're still you're still looking at something which is a very simplified representation of the SuDS in the system. Option three, which is included for completeness, but this actually doesn't use the sewage undertaker 1D model at all. So there's no sewer representation in here. It's just a two-dimensional surface mesh with the SuDS represented as either flow paths in the mesh or as storage, as depressions representing storage. Option four would be is more of an intermediate level that this uses the 1D sewer model, but still applies rainfall to the simple subcatchments approach, but that also adds a 2D surface mesh that water can be spilled into and out of. And the final option is option 5, and this is the most detailed and comprehensive representation of SuDS. It's a full 1D, 2D linked direct rainfall model where the rainfall is applied directly to the surface, and then there is full representation of the SuDS, of the infiltration, of the evapotranspiration, and of the interaction between the sewer performance, the SuDS performance, and the surface mesh. So this, as you'll see in the next slide, is the option that allows you to represent all the interactions that are going to give you those performance outcomes that the stakeholders are looking for. You can see that modelling SuDS requires a different approach to standard drainage modelling if you want to get all the impacts right. And that's because the proportion and the rate of runoff into the receiving pipe system is a function of the type and the configuration of the SuDS. So what you get out of the SuDS is going to be completely dependent on the relative surface area, on the volume, on the flow control rate, on the evaporation and infiltration rate. So a lot of different characteristics. And this just summarizes what you can and can't get out in terms of parameters from the different options. And sorry, I think one thing has dropped off the bottom, which is pluvial flooding. But what you can see is that it is option 5, which this detailed level modelling, which gives you, which is the one that allows you to get all the parameters, performance metrics from the model. I think it's important to remember at this stage that the use of modelling here is not about option appraisal. It's not about optimizing, seeing how much benefit you can get from the proportion of SuDS or the proportion of impermeable areas served within a catchment. This is about taking defined SuDS, defined areas, looking at the maximum volumes we could put in the model, and then looking at the model's specific modelled impacts of those solutions, and that's rather different to quite a number of other studies that have already been done on using modelling approaches. Okay, so the modelling method that we use, very simply, or relatively high level in this flowchart, the first 3 tasks here are about how we took the baseline 1D sewer model from United Utilities and adapted it in order that we could subsequently include the retrofit SuDS using that option 5 approach. So we needed to extract the sewer model and see how it performed. We needed to simplify that model. We needed to cut it down so that we had representation of the pilot study area and upstream and downstream areas that either contributed flow to that study area or were key influences on that study area performance, and also that gave us points downstream where we needed to extract those performance metrics. But what we needed to do is extract only the part of the model and the characteristics of the model that we needed to give us those performance metrics, and that was crucially to ensure that to minimise the model runtime, the model complexity, and the number of simulations that we needed to undertake, because that was also obviously critical. When you convert a 1D model to a 1D 2D model, you're necessarily massively increasing the computational complexity and then the demands of running a model. So we converted, having extracted the bit of the model we wanted and looking at its performance, we then converted that 1D model to a 1D 2D model within the pilot area. We then had to recheck the performance to see if it was similar to what the water company model, what the sewage undertaking model said before in 1D, and then we were confident that we had a baseline model that we could use to test the impact of our retrofit SuDS. So we created what we called a library of SuDS elements. We tried to make it get a consistent approach to defining all the aspects of all the SuDS components that we wanted to include in the model. So that will, and I will show you a library page later. And then those all had to be placed into the model and before the system could then be reviewed in the post retrofit scenario. Just a little bit about rainfall. We used 3 different rainfall types for the effect assessment of performance. The first type of rainfall we used was the standard design storms, which would be used routinely for looking at sewerage performance. And we looked at both present day and climate change uplifted summer rainfall, and we looked at multiple return periods, which were defined in the scope because that's what you needed for their funding application, and multiple durations because and that was to ensure that the simulation that all the critical durations or all the key points in the model area were represented within the model outputs. These were the storms, or this was the rainfall that was then used to assess those surface water flood risk and sewer flooding and surcharge metrics. So that could be compared to the standard outputs from the existing model, 1D model. We then used 3 years of time series rainfall. But we had to make adjustments to that time series in order to ensure that the computational demand of doing that was realistic. So we got our 3 years of time series of duration of rainfall, but we only picked every 5th rainfall event, and that was based on ranking those events by total depth. And that gave us a good picture of how of the performance of the system over those 3 years, using a range of representative rainfall events. And that time series rainfall was what was used to assess the CSO spill impacts, the frequency and volumes. And finally, we picked 2 rainfall events that represented a regular rainfall event in the system, a 4 millimetre event, and also a 12.5 millimetre event, which reflected a significant event that's going to happen maybe a couple, or maybe 3 or 4, a few times a year. And these two were used to infer the benefits of the SuDS in terms of how much volume they were going to infiltrate and how much volume they were going to attenuate into the receiving sewer. And those also were used to infer the volumes that were going to be that were potentially the impact on volumes pumped in the sewer catchment and flows to the wastewater treatment works. Oh, sorry. Okay, in terms of the standard SuDS library, the standard SuDS representation within the model, essentially we did have two slightly adapted different approaches. One for things like tree pits, where the area of the SuDS was relatively small in comparison to the contributing impervious area, and for which evapotranspiration was not included, and for which the model, the SuDS itself was not, the area of the SuDS was not then taken out of the 2D mesh that was also there. So where the area was not considered significant, we used just what we called a point SuDS representation, and then for larger areas such as this, swales and the large bioretention areas or basins, we used a storage node that had the full area considered. So, but essentially they were very similar. A new storage node was included, and that storage included level and plan area elevation curve and the infiltration and evapotranspiration rate. We created new gully nodes to represent curbs that would convey the water from the road into the SuDS. We put in non-return valves and orifices to make sure that we were controlling the flow back into the sewer, as Phil has discussed. We represented the SuDS subcatchment and the rainfall landing on that SuDS and how that was incorporated into the flows. We voided that area out where it was significant out of the 2D mesh to make sure we weren't double counting it. And then we had to add some spill lines around the SuDS plan area to convey the flow both into the SuDS element from the runoff, the mesh runoff area, and also to convey excess flow where the SuDS element was full back out onto the road network. And this is what the SuDS model library looked like. You've got for a bioretention zone, you've just got a consistent representation of the different all of the various parameters that you're putting into the model, and then a storage level array, and that was so we've got consistent documentation. And we also had consistency in how the nodes and the connectivity between that was defined through the modelling. Just some images of showing, well, the pink areas on the top right image are from Phil's work, where we identified all the contributing areas. So all the road network areas of road and impervious surfacing that had the right fall and from which we could disconnect the highway, the gullies, and transfer the water to the SuDS system. On the right hand side, it's an image of the model. The model as adapted to include the retrofit SuDS, all the connections into the sewer network, and from the new gully nodes. And you can see here whether this is a location where there's both a combined sewer and a storm surface water sewer as well. So you can see how closely they lie in the system, and that does add extra complexity. And this is just an image showing Birch Road with its multiple bioretention zones, or tree pits and bioretention zones going all the way down the street, and the complexity of representing all the surface water interactions with that. Just before I talk about the outcomes, we've got, I just thought I'd mention that the two different scales of reporting. So you've got we're interested in the local area, obviously, and that's the pilot area itself, which is represented on the left. And on the right, it just gives you an indication of where that pilot area is in terms of the combined sewer catchments and the wastewater treatment work. So they're very large catchments, total sewer catchments, and there's a relatively small local pilot area that we're dealing with. So this is just preparing you for the fact that clearly the impact on a much wider network is going to be inevitably limited. And this gives a bit more context for the scale of the SuDS and the scale of the area that they're managing. So we have got a plan area of SuDS proposed, as described by Phil, of over 8,000 meters squared, and that gives us a volume, a storage volume beneath that of within those systems components of 1,500 meters cubed, and the scale of the area discharging into those SuDS, impervious area discharging into those SuDS, was nearly 21,000 meters squared. But in contrast to that, the total impermeable area, even in the pilot area itself, we're talking at over 250,000 meters squared. So when you compare the proportion of the SuDS managed area to the impermeable area in the pilot area, you're only talking at about 8%. Looking at these representative rainfall events, the 4 millimeter event and the 12.5 millimeter event, for the 4 millimeter event, you can see here that the SuDS do really well. So they're infiltrating or evapotranspiring over 80% of all of the event, and with less than 20% being attenuated to the sewer, and that evens out a bit for the 12.5 millimeter event, but still being very effective. In terms of surface water flooding metrics and the proportion of area that's shifting between different or reducing in terms of at different flood depths, you've got a much lower impact, and that reflects the proportion of the impervious area that you're actually managing to address, but also or intercept, but also a function of where those flooded areas are. So these SuDS were selected based on many different characteristics and many different drivers, and weren't necessarily that the schemes weren't being specifically designed to address a specific flooding problem. So almost how well they did at reducing surface water flooding was an extra benefit rather than a specific objective for the individual locations. And again, you can see it in here that you're getting reductions, you're getting improvements, but they're relatively small and relatively not huge changes that you're looking at here. This is and I'm sorry, it's been missed off the top, but if I can move it, but this is a 5-year. This is a 5-year 60-minute rainfall event, and you can see from the different reporting locations that we've picked that where the proportion of upstream catchment served by the SuDS is significant, and where you've got it up to sort of 30%, then you do see a substantive change in the peak flow within the sewer. So it is just, as you would expect, reflective of how much of that upstream area you're actually dealing with, and also whether the system is a separate sewer system or has substantive flows within the combined system where you're going to have less of an impact. In terms of CSO spill volumes, we're then recognising that the pilot study SuDS area is a very small proportion of the combined sewer catchment, and therefore the change is commensurate of 2% in the right-hand column is commensurate with the level of management being afforded by the SuDS. So in terms of lessons learned, I think we learned a lot from undertaking the study. What we would probably say is that the value of taking a nested approach is really clear. So use simpler modelling options to give you an overview of the possible or potential benefits offered by different SuDS pilot areas, different locations, different types, and that's a really important first step. And also as a mechanism to give you a more understanding of the system and the likely benefits, so that you can potentially cut down on the metrics and those simulations to be carried out in the using the detailed modelling. But with the current sort of funding model and the needs of that funding model, then detailed analysis is obviously needed. But having taken the simpler approach, you can then use that detailed analysis to put in your outline SuDS design and provide with a good representation of that hydraulic performance that then will enable you to have a robust estimate of both the cost from Phil's work, but also the benefits to the receiving sewers and flooding. The other thing that we would say from this is that the importance of using time series rainfall and how much richer the information on SuDS impact is from using time series rainfall than you're going to get from design storms. That time series rainfall is going to give you it's going to reflect all the antecedent conditions in the SuDS prior to the events occurring. It's going to give you allow you to look at the combined effects of different critical durations in the system, and because we need to recognise that SuDS and storage systems and pipe systems will be under stress at different duration events. We need to time series rainfall gives us a much better handle on threshold frequencies, so when SuDS are full, under what conditions SuDS are full, and it gives us a much better idea of how the system can perform under different summer and winter conditions. And then, of course, it allows joint probabilities such as flows and streams and the combined sewer impacts as well. And crucially, it gives us an idea of volumetrically, so, and at an annual level, how much runoff we're taking out of the system through the year, which design storms don't. Recommendations, and these sort of move on from that or take those lessons learned forward, but identify and look at the existing modelling available for the study area clearly first, so that you really understand what that's telling you, and use that to pick your pilot areas. Through engagement with the stakeholders and the people that are likely contributing finance for the scheme, try and develop a set of performance metrics that are really going to not only meet the needs of the project appraisal process, but also the rest of the stakeholders, but also recognising ideally the likely value of SuDS for non-extreme rainfall management for those regular events, and recognising the implications of different metrics on the modelling approach that can be undertaken. Evaluate the networks and subcatchment areas to determine those potential pilot areas that might give you the best contribution to sewer performance. But obviously this is going to be dependent on what sort of stakeholders you've got and what's of greatest importance, and also all the links to potential highway infrastructure upgrades and other projects that might be going on in the area. So that there's always multiple things to consider. Simple area disconnection analysis can be used to give you a very, very first look at likely benefits, and then the detailed modelling should be used to look at the benefits in detail. And another thing to look at, as we did inevitably discover, is that some of the SuDS may be undersized and some of the SuDS may end up being oversized if you take the approach to putting in and identifying SuDS that are going to scale them to the space available rather than to the space that's actually needed to give you the maximum performance efficiency. Thank you, and that's it. Thank you very much.
Fantastic. Thank you, Bridget, very much. So that brings us to our expert panel. If I could invite all the speakers to turn on their webcams and microphones, please, Matt, Phil and Bridget. We've received some interesting questions from the audience. If you've not submitted your questions yet and want to ask something, now's the time to do so. To kick us off, I'll direct the first question to Matt, please, which was about whether there were any particular challenges with residents around the proposed works, or is everyone happy with the proposals, and how do you deal with people who object?
I guess we should probably just reflect on the stage that this is at. So we're having detailed conversations now with the Salford City Council, United Utilities around hopefully appetite and ambition to assemble some of the necessary funds to take some or all elements forward. So potentially using monies that might have come in from Section 106 or green recovery monies. So I think that then starts to iterate as to how much of the different elements that Phil has designed up will actually be deliverable. Will it be the entire sort of 3 pits along, I forget the name of the road, Phil, or will we have to deliver more of a demonstration in certain parts? So there's for residents and members of the public that are in areas, as was mentioned, there's been actual active sort of historic flood events, they'll be aware. It can be quite emotive, as we all know. There's some, but not all areas are kind of registered social landlord properties. Some areas actually, as Phil suggested, the parking and formalising it might actually mean that, you know, it's an improvement on the existing, certainly visually and in relation to the residents' sort of homes and amenity, it could be quite positive. So the sorts of images that Phil produced will be really good. So basically that's the next step, and to run in parallel once we get hopefully a positive indication that some or all of the Walkden neighbourhood street scale SuDS can be delivered, and working with the council who have experience of putting this in other places and taking space from potentially the kind of parking or streetscape. I suppose where it might be more of an in-depth discussion, I'm not quite sure, Phil, how well used that kind of, there's possibly utilising a bit of a public park, but there was also the area that maybe but maybe not gets used for kicking a ball around, that sort of thing. So that's when it starts to get in the real need to bring people along. But certainly some of those kind of general trees in the street environment and how much better that looks and what that gives will hopefully be quite a positive conversation with residents in the area over the next, say, 3 to 6 months, once we've got the green light to take it through to full business case and procurement and delivery. Fingers crossed.
Sorry, I was muted. Thanks, Matt. Next question I'm going to give to Bridget. What has been the value and learning of this work for the local authority and United Utilities, and how can this inspire replication of the approach? I direct it to Bridget, but if anybody else is better placed, please let me know.
There might be someone from the local authority actually on the call who might prefer to answer that question. And I'm not sure if anyone is available.
I mean, I can certainly, whilst whoever from Salford is on the call kind of collects their thoughts, because I think they've got history in this sort of area, but also experience in thinking about this particular opportunity. I think from the Ignition project's perspective, some of the value will come out of around actually understanding how you do practically the co-investment, how you buddy this up with potential planned highways works, how you work with land that's in the local authority ownership, the highways land. Potentially some of these areas of green space are actually linked to the registered social landlord, and how you physically get through that process of understanding the responsibility and the delivery of taking water off the highways, putting it on third-party land, controlling its release back in. So I think there's a lot of value for, you know, even if the kind of water management sort of flood risk reduction isn't there, I think there's a lot of value from our perspective in actually doing it and being in a position to understand better how it works and how it could work at significantly more scale. So the last slide where it showed that was sort of, I think, Bridget taking 8% of the wider kind of area of the 260,000 square meters in the area that was being looked at. I mean, yes, we can really need to design and model specific schemes against specific problems, but if we do take an approach that we also need to get sort of increased opportunistic spongification, if you like, of our urban areas, we need to know how this could possibly work and do it, and then put monitoring on the back end of the pipe to really understand if those benefits flow. So with my environment agency GM hat on, I think we get some benefits from doing and understanding how the different parties actually do it together.
Yeah, I would echo that. I would say that there's a real, all the other SUDS modelling studies have demonstrated that if you put in a high proportion of SUDS, you get a high level of return, and but if you're putting them in a very piecemeal approach and very distributed and very small scale like this, then you're going to be looking at local benefits, but not necessarily significant benefits more widely. But that's not to say that all the multiple benefits associated with making these changes don't give you sufficient benefits anyway, and also that yeah, as Matt says, gradually as things change, we need to take these opportunities to give us a more resilient city.
Thank you. I'm going to give the next question to Phil, if that's okay. At what point in the process did you apply the best assessment? Was it when you had the design proposal or also before that? And just to add that another person asked if there are any other types of assessment we use other than BEST and the evaluation tools.
So the outline purpose of this, which ties in with what Bridget and HR Wallingford was doing, was the hydrological benefit. That was sort of the primary purpose of this. So we identified the best locations for to give the maximum hydrological benefit, collecting the most amount of water, and then from that point on we designed the systems in, and then we did the best. Now, if there was a question, if we were coming from maybe a biodiversity route, we might be looking at the best doing the best assessment first ahead of this. But because we was doing it from the water route first, we was looking at we looked at the water, we did the design, and then we did the best assessment on top of that, sort of at the back end. And we looked at a number of scientific papers, so hence the reason why I looked at the Brydell and Stringer's paper for the trees. But we didn't want to go to look at too many different variations of BEST or similar versions of BEST, because we could quite easily find ourselves in a rabbit hole where one was giving us a benefit of say 5,000 and another was giving us a benefit of 10,000, or for another metric we was getting the reverse. So we just wanted to keep essentially with just one valuation tool and then keep it the same across all of it.
Yeah, great, thank you. There's another one for you, Phil, about ground conditions. What were the ground conditions like where permeable paving was used? Was there any infiltration, or was that connected back to the sewer?
So we didn't actually do any, as this was like sort of a pilot exercise, a proven exercise. We didn't do any SI investigations for the areas, and we suggest that an SI investigation is done prior to construction. But what we did do, and having knowledge of the area, we looked at a number of borehole records and things like that. So we made general assumptions for the areas based on what we know of this area of Salford, this area of Manchester. So we assumed like at least a 5% CBR above the pervious pavement, and we assumed that there was infiltration, although it was at a really poor rate, because this part of Manchester is quite clay, has natural clay soils anyways. So we assumed some infiltration, so some betterment from infiltration, but majority of the water going to back to sewer.
Thank you. Not quite sure who to ask this one. I might ask you, Bridget, but please pass on if that's not right. So the approvals and environmental risks of routing road drainage and other water from the catchment. How did the project assess the pollution potential stroke attenuation of infiltration drainage on the receiving water environment? So I think what it's asking is, yeah, pollution potential for receiving water.
So
I was just going to say that as part of our analysis for each of the areas, we did do the SuD simple index approach to identify the potential contaminants from the areas, which they are most of them seem to be car parks or sort of B roads. So there is sort of potential for oil, silt, and other debris, and then we did the simple index analysis for the mitigation measures that we put in to the system. So each of them passed that analysis. So we provided the correct amount of treatment for the potential contamination generated.
I'd say another probably point to note is that what we didn't look at as part of this was actual full disconnection of a highway runoff and then discharge into potential receiving surface water bodies instead of the sewer, and that would obviously require a detailed analysis of if that was possible. That would require a detailed analysis of the discharges to surface water, which we weren't doing here, but it would also give significant additional hydraulic benefits potentially if you could disconnect areas. So probably a key lesson learned is that for areas such as this is to identify where, if there are any locations where you could fully disconnect surface water runoff whilst protecting receiving surface waters.
Thank you. I'm just scrolling through the questions. A couple of people have been asking if the presentation and slides will be available afterwards, which they will. We've recorded the session, so we'll edit it and circulate it. And providing all the speakers are happy, we'll circulate their slides as PDF. Okay with you guys? Just bear with me. So a question about at Birch Road West, were there any issues with services with the tree pits and permeable paving on the footpath?
So we assume that there would be significant services beneath the ground at this location. The tree pit elements, we assume that because those tree pits are already there, the services would run underneath the roadway, the area where we'd be putting the pervious pavement. So we would be so we would sort of avoid the deeper part of, the deeper part of our mitigation, the tree pit part, would avoid the services, while the pervious pavement can sit above the services and run over the top of them. But again, this is prior to construction of this. We would recommend some sort of radar survey to identify these services before someone goes in with a digger.
The next one I've got is it's more of a comment really, but it's lovely. It says, all of this brought a tear to my eye. My first house was in Wallingford in 1976, and it's great to see such attention being paid to the area. Nice piece of feedback, I think. Another technical question, sorry, Phil. Can you give us an idea of the surface mesh size for the surface used? Seems to be important with respect to how flow does or does not enter the suds, features and gullies.
So it's probably to me. I didn't quite hear the beginning. Although my colleague Richard's on the line, he might want to ask this question. But could you repeat it, Louise?
Yeah, can you give us an idea of the surface mesh size for the surface used? Seems to be important with respect to how flow does or does not enter suds, features.
Okay, so I'm in as a surrogate, Bridget. I think you're fine. With regards to the mesh size, I do not have the specific mesh values that were actually used in the InfoWorks model. The actual modeler isn't present at the moment. But the key point was the need to have break lines for all the curb lines for the roads, and to make sure the mesh size was sufficiently fine on the road areas associated with the nominal gully locations where the flows were to be picked up and to pass into the suds. So effectively, it's a relatively fine mesh for the areas around the suds, and to make sure that the suds can also pass, flows can pass into the suds or out of the suds if they were full. But in other areas which are not on the roads themselves associated with the suds, you can coarsen up the mesh a little bit. But clearly, from a flood routing point of view, you need to make sure that the roads are acting as effectively as conduits in terms of overland flow when overland flow takes place.
Thanks, Richard. I've got another one for you guys. Was it ICM which Bridget used to model the existing and proposed networks? Would Bridget be able to give an estimate of hours required to produce and run the model?
Richard, you might need to be back for this. Did you say hours taken?
Hours required to produce and run the model.
Okay, so the network as a whole, the whole catchment for the CSOs down to the treatment works and all the upstream system is a considerable large model. I'm afraid, again, I don't recall the thousands of nodes, the actual number of nodes in the system. But a lot of effort was needed to be made in terms of converting a part of the model to a 2D system, and to check that the response of the network, because if you're applying direct rainfall onto the mesh, you end up with a very different response from the catchment potentially. So you need to check what the influence that has on the behavior of the network and the CSOs. And also you need to decide whether or not to model the whole of the network upstream or disconnect it and use inflow hydrographs. And you also need to define where the boundary is you disconnect and apply the 2D mesh, because you may have overland flow taking place from considerable areas outside of the suds areas that may be overland flows taking place from nodes that are outside the pilot area. So a lot of effort was made in trying to make sure that the converted model to the 2D system before we use the suds was giving you the same response in the downstream part of the network. Of course, if you had smaller networks, and then the upstream problem becomes much less of an issue. and then you may just convert your whole model to a 2D system. And the other point to mention was that the type of analysis influences your decisions on this matter, because the cost-benefit analysis that you use for the traditional approach to drainage analysis requires multiple design storms of various return periods and durations, which perhaps if you're looking at a SuDS analysis point of view, you might modify. And so you've got to look at it from the point of view of your criteria of analysis and runtimes as well.
But this project was all about learning lessons about transferability and of the methodology, and about the value of adopting different modelling approaches. So I think yeah, lots of lessons learned. Yeah.
Yes, I would say that this is a fairly unique study where there are a range of SuDS methods that have been used by various people in modelling SuDS and their benefits, and this was a very useful exercise which the industry as a whole will benefit from.
Thank you. We've got time for one more question. I don't think we have actually. What we'll do is pass the remaining questions to the presenters, and maybe try and get those answered and sent out to the delegates. Thanks again, everyone, for speaking. So, key messages from the day: lots of learning going on, lots of food for thought, input to future projects, and still preparation to do. But I think mainly the inclusion of all the stakeholders and understanding of their perspectives and what they value and how to distribute those values is really important. I want to thank everyone who's joined us for today's webinar. Matt, Phil and Bridget, thank you for your great talks. We'll circulate a link to speakers' presentations provided we have their consent. We'll endeavour to respond to any questions not covered today. If you've got any additional questions for our speakers, please contact the susdrain team. We're keen to hear about your webinar experience and be very grateful if you could complete the online survey, which will be emailed to you shortly. Thank you also again to our susdrain partners and supporters for their support in our ongoing programme of research and webinars. I've just got a few short announcements of things that might be of interest. First is the susdrain SuDS Awards. There's still time to submit entries to the awards. The closing date is the 31st of May. We're looking for submissions for outstanding SuDS from projects across the UK, and we also invite you to nominate your SuDS champion, including established professionals, rising stars of the SuDS world, and outstanding SuDS teams. The next thing is the Biodiversity Challenge and Awards. We're also accepting entries for this year's big award. This is taking biodiversity and to a site development or existing building. A bit longer deadline for that one, 10th of June. We have CIRIA's annual debate on the 14th of June to hear leading experts discuss the role and efficacy of natural flood management in reducing risk, and this is on the back of our hugely popular launch of our natural flood management manual, which came out in at the start of this month. And finally, if you're interested in SuDS training courses, there's the names of the training courses there. Please contact my colleague Nipa. And if you're interested in becoming a partner or supporter of susdrain, please do contact me or my colleague Adrian for more information. So thank you everyone for your time, and enjoy the rest of your day. Thanks for joining us. Goodbye.